The history of the atom is a long and complex one. From the early Greeks to modern-day quantum physics, the concept of the atom has evolved over time, as scientists have gradually come to understand the fundamental nature of matter and energy. The ancient Greeks were the first to develop a theory of the atom, based on their observations of the natural world. The philosopher Democritus proposed that all matter was made up of tiny, indivisible particles called atoms, which could not be further divided. This idea was in contrast to the views of his contemporaries, who believed that matter was made up of four basic elements: earth, air, fire, and water. However, the Greek theory of the atom was purely speculative, and it wasn't until the 17th century that scientists began to make concrete observations about the properties of matter. One of the key figures in this process was Robert Boyle, a British chemist who is often regarded as the founder of modern chemistry. Boyle's experiments with gases led him to develop the concept of the element, which he defined as a substance that could not be broken down into simpler substances by chemical means. He also observed that gases had unique properties that could be used to identify them, such as their density, boiling point, and reactivity. Another important figure in the history of the atom was John Dalton, a British scientist who lived in the early 19th century. Dalton is best known for his atomic theory, which proposed that all matter was made up of tiny, indivisible particles called atoms. He also suggested that atoms of different elements had different properties, such as mass and size, and that chemical reactions were simply the rearrangement of atoms between different substances. Dalton's atomic theory was a major breakthrough in the field of chemistry, and it led to a more systematic approach to the study of matter. However, it was not until the early 20th century that scientists began to unravel the complex structure of the atom itself. One of the key discoveries in this area was made by J.J. Thomson, a British physicist who was working with cathode rays in the late 19th century. Thomson discovered that cathode rays were actually streams of negatively charged particles, which he called electrons. He proposed that atoms were made up of a positively charged sphere with negatively charged electrons embedded within it, which became known as the plum pudding model of the atom. However, this model was soon challenged by the work of Ernest Rutherford, a New Zealand-born physicist who had moved to England to work with Thomson. Rutherford's experiments with alpha particles led him to propose a new model of the atom, in which the positive charge was concentrated in a small, dense nucleus at the center of the atom, with the electrons orbiting around it like planets around the Sun. Rutherford's model was a major breakthrough in the field of atomic physics, and it paved the way for further discoveries about the structure of the atom. One of the key figures in this process was Niels Bohr, a Danish physicist who worked with Rutherford at the University of Manchester in England. Bohr's theory of the atom proposed that electrons could only occupy certain orbits around the nucleus, and that they could jump from one orbit to another by absorbing or emitting energy in the form of light. This theory explained many of the experimental observations about the behavior of electrons in atoms, and it led to a more detailed understanding of the electronic structure of matter. In the decades that followed, scientists continued to refine their understanding of the atom, using a variety of experimental techniques and theoretical models. One of the key developments in this area was the development of quantum mechanics, a branch of physics that describes the behavior of matter and energy at the atomic and subatomic level.